How are we doing today? Is glad to finally be here to host the event for today once again. And today this happens to be the last session for this particular AZ-104 series. So I would like you to just sit back, relax, and enjoy the session for today. For this particular training, we'll be looking at administering your network traffic in Azure, and we'll be having none other than our LP in the house, Mr. Kofi Adai. Hello, Mr. Kofi. How are you doing today?
Hello, Promise. Yeah, I'm doing great. Thank you for having me once again on this ongoing AZ-104 session.
That's great. That's great. That's great. It's glad to have you on this session. So, what do you have for us today? Can you just give us like a brief on what you're about to, intro or give us,
Yeah,
or what we're about to learn today?
absolutely. So, like we did last week, we went into interconnectivity in Azure, and today's session is all about network traffic, administering network traffic on Azure. So, with this session, we're going to look into service endpoint, private link, and load balancer. So, I hope you guys are excited as I am to go through this session for today.
All right. Well, I'm excited to learn. I'm always willing to learn and happy to learn from you. So, right now, I'll be handing over the session to you. I'm going to be at the back end just watching out and moderating everything. So, please, the floor is yours.
Yeah, absolutely. All right. So, everyone, thank you for joining us on this session. So, as promised, this will be our last session for this AZ-104 program. So, if you have not already watched the other sessions, please make sure you check our YouTube channel and go through those sessions as well, because definitely it's going to help you out if you are interested in obviously writing the AZ 104 exams. So, like I said earlier, today's session is going to be about administer of network traffic. All right, so let's begin. So with this session, we're going to look into configuration of endpoint, service endpoint, load balancer, and also we're looking into application gateway. And if you do have the time, you'll go into the network watcher as well. So let's begin. So we'll begin with the service endpoint. So the key point here is that we're going to look into, first of all, the system routing. The key point is this. If you're obviously setting up any network, one of the key points is that you're going to have a predefined routing in place. So we're looking to that. And we're also looking into a user-defined route as well, and we run through a bit of the creation of the routing table, then we'll actually jump onto the service endpoint and private link as well. Right. So one of the key points, as I said earlier, is that when you come to networking, you need a routing table. So in a traditional sense, where you have on your on-prem environment, you have a routing table that will tell you how to get to certain resources. The same thing apply to Azure. So by default, in Azure, when you create a VNet, what will happen is that by default, it will create three sort of rules, which will be a traffic that will allow you to connect to the internet, one that will allow you to have intervened connectivity, and one that points to a load balancer. So that's what we call the system route. So these will be defined by default. So this will help the communication of any sort of like a device within those subnet, even if they are two separate subnet and they within the same VNet, by default they can talk to each other, unless of course you then define a rule to obviously prevent that from happening. So when you create a user defined route, that will take precedent over what we call the system route. So as you can see with the diagram in front here, there will be a system route created to the internet, and likewise there will be another one created between two subnet, as you can see here, two subnet, and all of them will be listed into the routing table. Let me quickly show you this routing table. Let me see if I can get my all right, so I'm just going to bring up my Azure environment. All right, so as preparation to this, I did create a few network, and also I created a few endpoints within the network. So as you can see from here, I have, for example, a VNet. Let's say I'm just trying to see the one that can easily demo what I want to show. So let's select the VNet here. All right. So within this, we have a subnet. All right, two subnet here, and we can check the connected devices. So we can actually select one of the interfaces. So when we select the connected device, we have the option to select one of the available interface. I'm just going to select port B because this one is a one interface which will have a public facing IP address. So when I select that, I can also see the IP configuration table here. So I'll just click on that, and let me see if I can select one of these. Yeah, don't worry. So what I'm looking for is the effective route here. So if you go right below the table, you should see effective routes. And once you click on that, so far as that VM or that specific node is up, it should populate with the route. The one that show us default the system route. So as you can see, I've created so I created a VNet pairing, so it will have that one established as well. But by default, once you create it for the first time, there will be few things that will be defined by default. There will be internet connectivity, and there will be a VNet connectivity as well. So that means this will allow any of those subnet within the same virtual network to have that communication. But of course, you can define your own route as well. So that's what we mean by the system route. So these will be created by default. So let's go back to our slide. Okay, so moving on, let's go to the user-defined route. So the user-defined route will be more like what you can define yourself. And the key point here is that you might have a firewall in your network, and you want to route all traffic on your subnet to that specific firewall for inspection before you leave to the public internet. So then what you want to do is, well, you want to have a way to route all those traffic through the application firewall before it leaves your network, and you can utilize what we call the routing table to really define this. So what we're going to do is, I'm just going to show you how you can achieve this. So we're going to create actually, I've already created one. It might take a bit of time, but can still run you us through the process. So we can create a routing table, and then we can add a route and associate a specific subnet to it. So let's quickly jump on back to our Azure. All right, so jumping back to it, to create a routing table, we first of all have to type in, let's say, search for the routing table object here. All right, so I have one created already, but to create it is quite simple. All you need to do is create a button here, create just like any other resource you create on Azure. You select your subscription and then your resource group. So in this case, I mean, I can just trying to see which one. Yeah, okay, let's select this resource group test, and you define the location where you want your original resource to be, and then you can give it a name. So I'll just name as a test TB for table, and then all you do is you just click on create. So after you've done that, that will create a similar object as this one here. So once it's created, you just simply come into the resource, and this is where you do most of your work. So first thing first, you can create a route to point to actually dedicate a specific IP address or specific resource to be where traffic will flow to. So once you create route, you just simply click on add. When you click on add, it will give you something like this, and then you define your resource. So just like on your on-prem network, when you define a resource 0.0.0/0, that indicator every single endpoint within that network should use this one as your, let's say, your gateway. So if users are trying to send traffic and that traffic is not that device is not within the same network as your in your network, then it will point to the default route. So that means everything else which is not in your network will point to application, the virtual appliance, which should be an appliance within your network, and then all the traffic will flow through it. So once you define this, this will show up on your effective route as well. So I've done this already. So if I go back to the table, so once you define uh, um, the route, you can then go back to the routing table, and then you define your subnet. So essentially, this will be devices in your network that can actually send traffic through the gateway. All right. So once you define it, all these devices, their gateway to the internet or the next hop will be the whatever you define under the root. So as you can see here, I've associated these to it. It's quite simple to do. So all you need to do is just click on associate, and then you select the network and then the subnet you want to use. That's about it. And then it's associated to it. So once associated to it, then if you then go to the subnet and then the devices within the subnet, you will notice that those devices now will have a route in place that point to uh, what you've defined here. So in this case, this IP address as the next hop, right? So if I quickly go to virtual machines and pick up a device which I know is in that network. So for example, there's a believe VM1 will be in the same subnet. So if I click on that one here, and then I click on the network to get into the network interface for that device, and click on that network interface, then scroll to the bottom here, and the effective route. So should populate momentarily. Okay, so under effective route, as you can see here now, the default one which was created when I created this specific a network interface, that is now classified invalid because the user route I've created will take precedent over that. So as you can see, the next hop is 10.0.0, and obviously you can tell you that this is a user-defined route with the name of um, the routing table that I have. So any traffic on this device, if the price is not defined here, it will send the traffic to the gateway, and this gateway obviously is a firewall, so it's going to do the normal inspection. I mean, I can demo this. I know time is not on our side, but let me quickly show you what I mean. So I'm just going to jump onto this device. And one more thing, one of the things I've done in terms of this device is that there is no public IP address for this device. So all traffic have to be routed through this hop here. All right. So the reason why I'm bringing this up is that if you want to access this resource, then the firewall have to have a route in place that will allow you to access those resources. For example, RDP to those resources. So I believe I have that in place already. Let me quickly check. So what I'll do is, right, let me go to the firewall, and then as you can see, let me pick up the public IP address of this firewall real quick, and I will try to SSH to it. Actually, there's an RDP already in place, and I've created an RDP session here. So hopefully by running an RDP, I should be able to jump onto the VM1. So what I will do is I will bring up a terminal. All right, let me just make this on the big screen. And then let me just RDP to this device. Okay, let me quickly jump back to just trying to check to see if the VM1 is up. Okay, so VM1 overview. Okay, so yeah, the VM1 is up, and for some reason I'm not able to connect to it. So what I can do is we can simply go to this device here, and then we can check to see if there's a root in place. So this is the firewall. Oops, wrong port number. Nine 663. Okay, so essentially, I'm just going to this Sophos XE firewall, and what I'm doing is, right, I'm just trying to see if there is a DNAT rule in place. So I can see that there is a DNAT rule in place to send traffic on our DP, and the IP address specified is 10.0.0.1. All right, so I can quickly check what that IP address is. Is it our VM1? Okay, so that one is our definitely our VM1. But the traffic is not hitting this. So in normal sense, the issue is more like troubleshooting the issue on this firewall just to establish where the issue is. Then we can find out what's going on. But whilst we are on this firewall, we can easily check the routing in place for this specific VNet. So if I go to the same device and I go to the effective route. So for example, this one here, click on the interface, and we drop down to the effective route. It will have the same routing table as VNet one. When actually this will have two interfaces. So depending on which interface we're looking at, it will have the route here. So we're looking at the right interface. So as you can see, everything leaving this network will go through 10.0.0.4, which is um, the LAN IP address of this device. So let me show you real quick. So if I drop down to networking, you notice that there is this IP address is the LAN IP address of that. So that means every traffic on this network will flow through this interface to leave the internet. So once you flow through this, then it will leave out through their port, the one port here. So what I can do is that I can SSH into this device, and I can show you the routing table as well. So if I copy that and bring this up in SSH, and we just paste the IP address and then just type yes. All right, so next up manager. All right, traceroute.com. Okay, it's not showing those routes. So effectively, what will happen is that whenever a traffic is leaving a network, it should flow through that. I can actually demonstrate it from the interface itself. So what we can do is, right, if you go into, let's say, the routing table, the diagnosis page here, and then under packet capture, we should be able to see if I can generate on traffic. So generating traffic from here, we can easily see that for the request that came in from the device, we can see that each request that comes in will leave out through port B, which will be the public facing IP. So that means every traffic that comes into the network will leave out through this internet. And once it hit the LAN A, the LAN A will then forward the traffic through the LAN B of that specific network. So this device here will have two interfaces. So this one here, if I jump to networking, there will be B and also A. So the traffic, everything will flow through the B, which will be the 10.10, sorry, the 10.0.1.4. So as you can see from here, that will be that IP address there. Okay. All right, so let's jump on to back to the slides. Okay, so moving on, we're just going to move on to the service endpoint and how we can actually utilize the service endpoint. So in this session, the service endpoint is more like a special type of configuration that allow us to integrate different services with our virtual network. So when we talk about service endpoint, there is really three main things that we can achieve. Firstly, we can configure private connectivity between supported Azure services and also resources within our private virtual network. Now that the path of the virtual connectivity that we configure with service endpoint, for example, as you can see on the screen here, when you create a service endpoint, literally, it will create a path between from, let's say, our virtual endpoint or virtual network to Azure resources like storage, databases, or whatever you. But the key point is that whenever you create a service endpoint, it rely on the Azure backbone network. It's not going to send the traffic over the public internet. So this give you an extra possibility of ensuring that your traffic does not traverse over the public internet. So then you can even go to the next step of creating a policy that allow only traffic from your virtual network to access certain resources, and then block any traffic from the internet. That create a level of security. It's not really a must that you do that, but that will be a level of security that you can think about when you're utilizing these type of services. You can even go further if you have on-prem resources that also access these Azure resources. Then you can also create a rule that ensure that only traffic flowing from your on-prem network to be sent to those resources. So effectively, any IP address you've not defined within your that specific service gate and firewall, they will not be able to connect to it. Let me quickly show you what I mean by that. So I'm just going to bring up our, let me just bring this up again. Okay, right. So I do have multiple VMs here, so I'm just trying to see which one I can use for this. Okay, I know there is a network here, so let me just go back to the virtual network. So in the virtual network, let me select, let's say USNet, and then select a subnet. All right, so with this subnet, you can use service endpoint to ensure that when this subnet, any device within the subnet, for example, devices like this one here, if you want to access, let's say, your storage, right, you want it to go through the Azure backbone network. It will give you a high throughput, better latency as well, and obviously it's not going to traverse over the public internet as well. So the way you do this by selecting that specific subnet, and within that blade, you have the option of defining your service endpoint, and then you select a specific resource you want to do. But one thing you have to keep in mind is that not all services will be available. Like every other service on Azure, there will be certain scenarios whereby certain resources are not really available in certain regions. So that's one of the things you have to keep in mind. But you can actually find out if wherever you want to, the service you want to access is there or not. But obviously, once you click on it, you can see those resources here, or equally, you can utilize there's an option to also check from the back end. Let me see if I can remember the command. So that'll be AZ, I believe network, and then VNet, and list service, I think endpoint services. And then you can define the specific location you want. So let's say in this case, East US. Let me put that into East US, and let's put this in the table form. All right, so this will give you the list of resources you can actually create service point for in a specific location is yours. So when you're creating, that's one of the key things you can actually do to understand which sources are available in terms of the service endpoint. So once you have that, you can then obviously create that resource by coming in here and selecting the specific resource, and you just simply hit on create. Okay, this one wouldn't really take that long. So once that service endpoint is created, that means these resources can access the storage, but it wouldn't go through the public internet. It will go through the Microsoft backbone network. And like I say, you can now put extra layer of security in place. So what you can do in that case is that you can literally then go into the storage component of the Azure, and the service is created now. So actually, let me just demo this one to you. So if I now go into storage, and I know this storage here is actually in the same region. So what I can do is then I can then go into the network blade here and add this security in place. So as you can see, at the moment, this storage is open to everything, right? So to add an extra level of security to ensure that only resources within my VNet can access this, and then exempt any connection from the internet, I can literally enable from selected network and IP addresses. And what I can do from here is that I can use an existing VNet, select that specific VNet. So in this scenario, that one is in US net. Then I can now select the subnet and then I'll add. So literally, when I create this one, only this subnet will have access to this storage, and no other IP address on the internet can actually access it. So equally, once I define this, I can also add my own kind of like if I have on-prem resources that I need to get access that need access to this, I can also define those ones here, so that my on-prem resources. And so let me just bring up my on-prem resources can also have access to it, and my virtual machines in my subnet can also have access to those resources, and no other device on the internet can have access to it. So that's one of the key things you get when you're using the service endpoint, giving you the ability to access your resources through the Azure backbone. And also, if you do go put an extra layer of security by defining a file security on that resource to only allow resource from your on-prem and also on your VNet. It will ensure that uh, bad actors on the public internet wouldn't have access to those resources. Because one of the issues that we have when you create, let's say, storage in the past is that, especially with AWS, was that those services were publicly available, and sometimes there's if your users maybe just access those resources from the on-premises or from resources within Azure, there's no point just making it available online. You just have to put these extra measures in place, and Service Endpoint will give you this opportunity to leverage on this. Right. So moving on, let me bring up my slides again. So now let's move on to private link. Right. So we're going to have a look at how we can use a private link to integrate specific Microsoft services within our virtual network. We will discuss how this is both similar but different to Service Endpoint. And we also jump into Azure Portal and create a private link, just like we did with the Service Endpoint, and see how it works. So the first thing to understand about Azure Private Link is that when we talk about private link, it's about providing private connectivity for resources in a virtual network to Azure services. But this is a key point. It will give you a private IP address. So as we saw with the service endpoint, it will create that opportunity for you to have your virtual network access those resources, but you won't get any private IP address. So the rare message here is that there is a private IP address involved here. So we do still get the familiar optimized backbone routing that we have with service endpoint when we use private link. Not only that, but also we can have access to other resources. So it support access to Microsoft services, right? But if you have your own, for example, if you have a partner company that want to access your resource, right? You can also use a private link to give you that opportunity. So one of the things I'm going to do is I'm just going to bring up the private link, and then I can walk you through the whole process. Okay, so back to the Azure portal. Let's cancel this one out. And then for private link, we can access the private link by just searching for private link in the search option here, or even you can even go to the specific resource and create a private link from there as well. So we click on private link, and like I said, with the private link, you can have an IP address within the same resource. So as we saw earlier with the subnet one, which we created a service endpoint with a private link, it will create an IP address within the same subnet, and then you can use that one to access resources, Azure, Microsoft service resources, or your partner or your partner who want to access, or a different organization want to access your resource can also probably set up a VPN or express route and then access those resources, obviously pointing to that specific service endpoint IP, private IP address. So I'm just going to show you how you can create one. So to create this, all you need to do is just click on the private endpoint here. And just like any other resource on Azure, you just simply click on create. And once you click on create, you define those resources. So what I'll do is, all right, I'm just going to select, let's say, test RG, and then you can define the name. So let me say private one or something. All right, just going to make sure that I have a resource in that location. So I think I have a resource, storage resource in test2. So that's the reason why I changed that. So the region will change to East US. So that's one of the key points. It have to be in the same region. So once I select that region, I can now go to the resource. And from here, I will now define the resource I want to essentially to access. So I'll select the resource type. So in this scenario, I just want to have a private connection to a storage account. So all I can do is just select a storage account. And another key point with private link is that you can actually go a bit further. So we see with the service endpoint, when I was creating or drawing the configuration, I selected the storage object. But in this case, I can go further by selecting the blob or the file or the queue. So that means you can go a bit more granular compared to using service endpoint. That's another key factor as well. So if I select, let's say, for example, I select the storage, then I can now have as an opportunity to select the sub resource as well. So in that case, I can select a specific blob within that specific storage. So you don't really get this option when you're using a service endpoint. So that's another key factor. If you want to go granular, then the better, because at the end, the more granular you go, the better security it provides. Because you need to ensure that whatever access you're giving or permission you're giving to people, you want to make sure that you only give them what they really need, and then ensure that they don't have access to other resources that they don't need to have access to. So in this case, I can say a blob. And when I go to the networking session, that's where we define which network can actually have access to those resources. But like I said, the key point here is that it will create, I'm not going to have a unique subnet. So just think about last week when we were creating the VPN gateway. We need a unique subnet for that VPN gateway to obviously to work. But in this server link, no, doesn't. It's not the case. It will utilize or pick up an IP address from the same subnet that you want to use. So in this case, US1, it got 250 available IP address. An IP address will be issued from within that 250 to the server link. So that the server link will have that IP address. It will be dynamically allocated. But if you want, you can also allocate one statically. So you can have the option here. So dynamically allocate an IP address, or you can then select this option and define your own IP address if you want to have a static one as well. The other key point is that it will have you can define a DNS name here. So when you are integrating the private link, you have the option to select yes, and then it will follow these sort of like a naming scheme: a private link plop called Windows hyphen net. Then it will specify the subscription, the resource, and then the name essentially. So it will give it a naming scheme like this. So all you have to do is just define that naming scheme, and then if you want to add tags, you add the tags, and that's about it. So you run through the verification checks, and then once the verification checks is confirmed, it will create your resource, and then it will have a DNS entry as well. All right. So I'm not going to create this, but once you create this, then you have access to this blob. So if you a client on a network within the same subnet want to access it, they can. And then just like we did with the service endpoint, you can then obviously create use a firewall on that specific service or resources to block access to any other IP address. And then yeah, so when we come back here, you can then, once you have the service endpoint created, so if I go here, once I have the service endpoint connection, I can now restrict it to just that subnet. So that will create a level of security as well. Okay, so let's move on. Okay, so this is the end of the service endpoint. I'll actually add a link which will show you how to create one yourself. So that's a Microsoft lane, and you can follow through with that one to create your own service endpoint. So moving on, let's look into Azure Load Balancer. So what we're going to look into this is that we're going to look into load balancer solutions that we have, and then we look into creation of a load balancer, talk about the different skills and tools, and also the rules that you need to create when you're creating a load balancer. So now let's look at the options that you get when you select a load balancer. So when we think about a solution that we want to deploy, you always want a solution to be highly available. So that's where the load balancer comes in. We should know that we need to do so. Think about redundancy to ensure that the services are highly redundant, because when you're creating a resource, you don't want a situation whereby a service goes down and then no one can access your resource. So you create, for example, if you are creating a web server, the web server will probably have three devices that can have serve the same resources, right? If you're not using the load balancer, you're thinking, okay, am I going to manually change, let's say, a DNS entry to point to another server whenever the server goes down? That is too much of a manual approach, and in a scenario whereby you want your service to be highly available, you don't want to be doing a manual process. You want something that is highly effective. That's where a load balancer comes in. And Azure have different load balancer solution depending on what you want. So we do have the application gateway load balancer, and this will give you um, access to resources both on your if you have resources on your prem or in Azure, you can all integrate all of them into a pool of services that can be used for load balancer. Because when you're creating a load balancer, another key point is that there's a probe, a health probe that can be created to see whether that specific server is up and running, right? So then if that one goes down, then you can obviously leverage on another. So with the application load balancer, you also get a web application firewall. So essentially the web application firewall have the OWASP framework where it can check against certain type of known exploits so that it can protect your resources against those known exploits. Or if those are occurring, it can easily identify that and block those traffic accordingly or notify you accordingly as well. The front door, a load balancer gateway also have it's kind of highly scalable. It's on a global level compared to the application gateway, which will be more like a regional base. But with this, it also give you the option of using a WAF as well. Right, and the one we'll be talking about today as well will be the load balancer. So with AZ-104, it focused mostly on application gateway and also load balancer as well. So with this option, mostly we'll be focusing on protocols like TCP and UDP, and also it will be structured around resources on Azure. Not you cannot obviously extend it to other regions or extend it to your on-prem resources as well. The other option in terms of solutions that you get in terms of creating a load balancer is traffic manager, utilizing DNS for that purpose. There are multiple um, kind of like solutions you can use when it comes to the traffic manager. All right, so all right, now with load balancer, one of the key things is that when you are building a load balancer, it will more likely focus on either it's going to be public load balancer or a private internal load balancer. So sometimes you will want a resource within your network to be more like have load balancer as well, so you can think about it that way. You need that redundancy, and then you can take advantage of that. So those are the key points that you need to think about when you are creating a load balancer. There will be a private, and also there can be a public one as well. So I have and then the slide talks about the private. So you have the private, you have a different layers. There will be a layer whereby the front facing services like your web service will have access to, will have the let's say specific port enable, and then inside you probably will have those resources pointing to let's say database here, and those who have another internalized load balancer to serve those resources. So that means those resources will be highly available and highly redundant as well. All right, so looking at some of the SKUs, so we do have two SKUs when it comes to the load balancer. There's a basic SKU and there's a standard SKU as well. So with a basic, you get up to 300 instances. So that means the backend service, you can go as much as 300, but the standard, which is more tailored for on-prem, sorry, tailored for production, will have about 1,000 instances. And the health probe for basic, you only have two protocols essentially, TCP and HTTP. But once you move to the standard, you have the option to have HTTPS as well. And when we come to basic, there is no availability zone, but with standard, you can leverage on zone redundancy and zonal front-end redundancy. The key point is that it provides extra level of redundancy in the sense that if anything happened to a specific zone or a specific data center, it will not have an impact on your resources, since your resources probably are hosted on another uh, regional data center as well. Data center as well. And in terms of the front end, the basic one, you only have the inbound only traffic coming in, but with the standard, you can have inbound and outbound. So for instances, the certain scenario, you want to set up a SNAT to ensure that traffic from those resources behind the load balancer, you want to route them out to a specific gateway. You can define that as well. And by default, there's the basic SKU. There's an option for NSG, but by default they are open. But the standard one are closed by default, and the SLA for the standard 99.99. So when we talk about um, creating a production environment, the standard is always a recommended approach. And creating a load balancer, one of the key points is that you can select the backend pool. So the backend pools will be the resources that you want to be part of that specific pool of resources that you can pull resources from. But another key point is that creating this, you need to ensure that those resources are similar. So for a website, both of these, let's say VMs, should run the same web services. You cannot have a mixture of, let's say, um, a web tier and database in the same pool of backend pool. They have to be a similar object because you want, the key point is that you want to ensure that that specific resources are highly available, not having a mixture of those resources. So that's another important point. So once you've defined those, you then have to create what we call a load balancer rule. So that'll be putting everything together, the front-end IP address, the backend pool, the help probe, you put all of them together, and then it will have you establish that load balancer effectively. So this is what we have it here, load balancer rule. So you define all those parameters essentially. Okay, and another key point is that you can also create what we call the session persistence. So the session persistence is that when a user says setting resource, you want to ensure that any any connections that come in later on all flow to the same VM. So there will be certain service that requires that, especially banking application. They want to have ensure that those services are pointing to the same service or resource or VM or for every connection. So that's what you can actually do. So let me quickly jump to, all right, so I'm just going to quickly bring up, yeah. So just going to show you how this can be created. It's quite simple. All you have to do is just type in load balancer, and then you click on create. So in here, then you, like always, you select the resource group. So I do have two servers here. So I can select the resource group, and then I can give it a name as, let's say, LB, I'm just doing load balancer 1. Then select your region, and here is a SKU. So there's a standard, the basic, then there's a newer one called the gateway SKU. And you can select whether you want this load balancer to be public or internal. So in this scenario, I have web service, so I want to make it public, but there will be certain scenarios where you want to think about internal based one. So these resources are all regionally based, so you can then select regional, then move on to the next blade, and I can define the front IP address. You see here, I don't have the option to review and create. In the past, this option could have been created uh, after you've defined your load balance, but now you don't have that ability anymore. You need to define the front end IP address. So quite kind of a simple one. It's just defining a public IP address that you want to use for the load balancer. So I can name it LB public IP, and you can select from your pre-existing IP addresses. So I have a test public 1, IP address, I can use that. And then all you do is just click on add to add that. And then now you have the option to continue doing these other ones after you've created a load balancer. But because of time, what I'll do is I'll just follow through this and I'll show you. So the next option is to define your backend pool. So your backend pool, you just click on add backend pool. And then in here, you give the backend pool a name. So I'll just name it backend1 and virtual network. So this is where you select which virtual network you want to use for this service. So in this case, yeah, I'll use this one here. And now I can select those IP addresses or those resources. So if I click on add, I have these two servers deployed in that subnet. So I can now select these two as the backend pool. So this will have a web service on it and it will serve those content. So I can now click on add and then I'll save that. So those are the pool. You can obviously add more to it if you want to. So click on save and move on to the inbound rule. All right, if I have any inbound rule I want to configure, then obviously I will configure it here. So to do that, you click on the load balancer rule here, and then you will give that a name. So this will be the rule that will actually contain everything that you want to do, your front-end IP address, your backend pool, and the ports you want to access those resources on. So I can name it, let's say, load balancer rule 1 or something, because it can have multiple rules. And then I select the front-end IP address I defined earlier. Then I can define my backend pool. I've also defined as well here. And I'll select the protocol, TCP, UDP, and I can define a port that I want those resources access on. And equally, the backend, I will also have to define the port needed for the backend access. And I can now, if I have a health probe, I can select it. But if I don't, then I can create an health probe. So essentially, this is a probe to check whether those backend pools are active. If the probe fails, then it knows that a VM or that server is down. So I don't have to serve it any resource. So I then define how I want to do it. So I can use HTTP, TCP, or HTTPS. So in this case, I'll say HTTP, select port 80, and you can have other parameters, define the intervals you want to do the checks as well. And then just simply, sorry, I forgot to add a name. So I can name it health 1, and then I can click on create. Now, like I said in the PDF, or sorry, in the PowerPoint slide, you can create persistence so that when you define those persistent, when the traffic comes into a specific VM, that client will always be served by the same VM or the same web server for that session. So once you're done with that, you simply click on add. And then you can also set up an inbound NAT rule to a specific VM. So for example, you want to probably connect to those VM SSH to it to do whatever. You can do that as well by creating an inbound rule. So what you can also do is you can also define an outbound rule for certain VM to send traffic through the from the backend to send traffic to the internet or whatever service by you setting up a SNAT rule. So once you're done, you simply just click on review and create, and that's about it. And then you create your load balancer. All right.
Wow, what an interesting session, Sophie.
Yeah, I know. I know time was going to be against us.
Yes, but funny enough, I think you were able to cover the basics and you even had the time to give us some practical sessions. So I feel like it was a very interesting session.
Yeah, that's great. That's great.
Yes.
So Thank you. Thank you for having me. I'm hoping that probably in the future we might have other longer sessions that we can demo with the others. So, uh,
Definitely,
but
definitely,
I'm hoping
definitely.
that people got the gist of how to obviously create a load balancer, how to create service endpoint, how to create private link, so and also how to create a routing table. So
Yes,
uh,
yes. I believe they did because I myself was able to learn one or two things as well.
that's great. It's great to know.
All right. Thank you very much, Sakofi. It was actually great getting to, you know, hear from you.
Absolutely.
So, yeah. So, at this point, I want to thank everyone who participated during the session. I mean, it was just nice getting to hear from Sakofi, and he was actually the one who helped us round off this session on the AZ-104 series. So, thank you very much, Sakofi.
Thank you. Thank you. And thank everyone
Oh,
for your time.
all right. You're welcome. So, at this point, we'll be rounding off the session for today. And I just want to say thank you, everyone, for joining this session. Definitely, as the Azure Nigeria community, we still have other programs for you that are going to be lined up. So please stay tuned. If you are not following our social media pages, please ensure you do. You could follow LinkedIn pages to get more updates on what is going on. We also have a group on LinkedIn or a page on LinkedIn called Azure Nigeria Community. So please ensure to follow that. Subscribe on our YouTube page, and we'll be in touch with programs which will be coming up. Right now, we have rounded up the AZ-104 series, but we'll also be starting other series as time goes on. So thank you very much. It was nice hosting this session. My name is none other than Promise Uche Nwachiko. See you all. Bye bye.